Good morning, students. It is April 20th, Monday. Today we will be talking about what I believe will most likely be our last topic for this abbreviated 9 weeks this semester, and that's going to be the idea of logarithms. Now, it says here, what I have here is a blank copy of your notes first before I get into the discussion. And I do want to say that I understand that printer ink for some of us is hard to come by. It is expensive, I get it. So, of course, you don't have to print out the notes, and you could just always write on a separate sheet of paper the big ideas. For example, like the notes we're going to have up here in just a few moments. And then the examples, of course, you can also write out on your own notebook paper or blank paper, whatever you have to use to do your assignment. So by no means are you required to print out the notes, and I haven't even been asking you guys to show me the work. I was going to make you guys do that, but I figured to just make life easy for all of us, and I've only been requiring answers. This topic, although the word logarithm may look a little intimidating, it is actually quite easy. Pardon the noise, that's my dog scratching himself and his collar. That's right, Bruce. Are you done yet? Thank you, sir. All right, so back to our notes. So our topic today is what is a logarithm? And just in the same similar fashion as last week, I'm going to go ahead and show you the nice and easy completed notes and explain them as they pertain to this assignment. So here's the blank version, and what you're going to want to do is start writing down basically everything that comes after this point. So first of all, a logarithm. We're asked, what is a logarithm? A logarithm, which we'll refer to in shorthand as log, is just another way of writing exponents. For example, if you have, and I'm going to kind of give the example backwards. Well, I guess I'll go this way. So we have the word log. That means we're working backwards with exponents. The way it works is you have log to a certain base. And it's always a little itty bitty number written down here next to the word log. And basically what you're asking yourself is, if you know what your base is in an exponent, and you know what number you want it to equal to, which we'll call a, you want to know what exponent would you have to make it to. And that's kind of the gist of what the whole idea is. In reverse form, the way we were used to seeing it is we have some number, we multiply it times itself a certain number of times, and we get our answer a. So basically, it's like a backwards version of writing exponents. All right, so having explained that, let's go ahead and go into our examples. So the first 6 examples in your notes, all they're going to do is show you how logarithms and exponents are related. So what we're going to do in the first section is convert logarithms into exponential form. The directions say write each equation in exponential form. That means with an exponent answer, something with an exponent equals some number. So for example, if you see the equation, the log of base 3, and here's how you read it, the log of base 3 of 9 equals 2. The way you should understand it is that you have a base of 3, which is this number right here. You want to know what exponent would you have to raise it to get an answer of 9. Well, 3 squared is 9. So log base 3 of 9 equals 2. That means a number with a base of 3, we need to have an exponent of 2 to give you this inside number of 9. And it's the same thing for number 2. If you have log base 6 of 216, what would that equal? It equals 3. That means if you have 6 to the 3rd power, you get an answer of 216. It's just using exponents basically backwards, working backwards, because sometimes you don't always have a starting number or an exponent given to you. You have an answer and you have a base, but you don't know what exponent. And logarithms give that to you. Now let's practice rewriting some more. Log base 7 of 1 equals 0. That means 7 to the 0 power equals 1. And that is one of our exponential rules. Anything to the 0 power is always 1. Number 4, log base 2 of 16 equals 4. That means a number with a base 2 to the 4th power will give you an answer of 16. It's just another way of writing exponents, another way of thinking. Number 5, log base 4 of 1/16 equals negative 2. So we know to get from a 4 to a 16, 4 squared. So you could say 4 to the 2nd power. However, remember our rules for exponents. Whenever you have a number exponent in the denominator, it has to be a negative. Whenever you have a number in the denominator, you're going to have a negative exponent. So yes, 4 squared is 16, but since the 16 is in the denominator, it needs to be made negative. That was one of our rules of exponents, which I included a rule sheet in our last assignment from last week. You can always download that. Number 6, log base 9 of 27 equals 3 halves. That means if you took 9 and raised it to the 3 halves power, you would get an answer of 27. So these first 6 weren't solving anything, you were just rewriting a logarithm into exponential form. And your assignment's going to be very similar to that also. I believe the first 3 on your assignment are going to be just like this. So you're not solving, you're just rewriting. So you shouldn't really miss anything up. It's this little number becomes your base, because it is the base, with the answer as your exponent, and whatever your inside number is becomes your answer. It's just shuffling the numbers around. Not too big a deal. Now we're going to work into converting exponents or exponential form into logarithmic form. Write each equation in logarithmic form. So the only difference now is you're going to reshuffle again, and you're going to throw the word log in there. That's basically all you're saying. So you're saying log, because you're writing a logarithm. You start off with the word log. What's your base? Your base is 14. So you make that your little number down here. What do you want it to equal? I want it to equal 196. So you write it right there. Equal sign. Well, what exponent did you use to get that answer? I used a 2. Bam. There you go. That's all it is. Same thing over here. You begin with the word log. And then you say, what's my base? It's 3. What answer did I want to get for my equation up here? I got an 81. What exponent did I use? I used a 4, because 3 to the 4th power equals 81. It's just rewriting. Number 9. You start off with the word log. What's your base? It's 12. What answer did you get? I got a 12. 12 to what power would give you a 12? Well, that would be a 1. That's how you think about it. Let's go ahead and go on to number 10. Start off with the word log. What's our base? It's this big number 36 right here. What exponent am I raising it to? I'm raising it to the 6, not exponent. What answer am I trying to get? A 6. So to go from a 36 to a 6, you know you're going to have something smaller than the number 1. And what exponent should I be using? Well, it tells me right here, I should use a 1/2. 36 to the 1/2 power equals 6. And don't forget, anything to the 1/2 power is the same thing as square root. I'm sure many of us forgot that or are trying to put that horrible nightmare behind us, but it is a thing that comes back up again because, math. That's how we math. Number 11, 2 to the negative 3rd equals 1/8. Start off with the word log. What's your base? Your base is 2. Goes down here. What did you want your answer to equal? 1/8. Look how we kept it in fraction form. That's okay for this because our answer ends up being negative 3rd. So for this one, there was absolutely no equation solving. You're just rewriting. And same thing for number 12. You begin with the word log, and you say, what's my base? It's this number 8. What's the answer I want to get out of this equation? I want to get a 16, or I got a 16. What exponent did I raise it to originally? I raised it to the 4/3 power. Now, if you are required to put a decimal answer into the Google form, remember, only go to 2 decimal places. And if you need to, add a 0 in case your answer only goes to 1 decimal place. If your answer is a whole number answer, then by all means, just give me that whole number answer. All right? So don't stress out about that. So we're almost done. Let's go ahead and go on. And yes, my dogs, if you can't hear them, because my microphone is pretty sensitive, they are playing around because, at 6 in the morning, nothing like a bunch of dogs who want to just hang out and have a lot of fun. All right. So now the back. Common logarithm. Common logarithm with a base 10 is called, let me rephrase that. A logarithm with a base 10 is called the common logarithm and can be written without the base. So what this is saying is whenever you see the word log, it's understood that we're talking about a base of 10. And we use 10 most of the time. It's called common because that's how we count our numbers. There are different number counting systems, but typically we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 10 digits. So that's why we say it's a common log. That's where the 10 comes from. Now, The note is log base 10 of x means log of x. So if you don't see a number down here, that's kind of the big idea. If you don't see a number down here, you can just assume it's 10. All right? Excuse me. So let's go on. Evaluating logarithms. So our instructions say, or our directions, use your knowledge of exponents. You may need to print out that sheet from last week to evaluate. That means we're going to be doing some solving now. The following logarithms. So here we have log 7 of 49. And really the way it should be written is log 7 of 49 equals what? Well, we don't know, so let's figure this out. If we rewrite it using the rules from the front, we get base 7 to some unknown number equals 49. Well, 7 to the what power equals 49? If you know your times tables, you know 7 times 7 is 49. That means 7 squared, or 7 to the second power. All right, now let's go ahead and go on to log base 3 of 27 equals, I'm going to write equals x. So if we rewrite it, we have 3 to what power will give me a 27? Well, 3 to the first power would just be 3. 3 to the second power, 3 squared would be 9, so I'm still too small. 3 to the third power would be 3 times 3 times 3, which would give me 27. So it really got to kind of know your times tables here. So x would equal 3. Let's keep going. Now remember, the word evaluate means you will have answers. Number 15. Notice it says log 100. There is no base written right here. So what I'm going to do is write equals x. That's a really ugly way of writing it, but it means equals x. So log, and according to our rule up here, if we don't see a little number, a base, it automatically means 10. So I have 10 to the what power equals 100. Well, I know 10 times 10, or 10 squared, equals 100. Now I have log, and they give me a base of 12, 1, or log base 12 of 1 equals x. That means 12 to the x power equals 1. What would x have to be? Well, one of our exponential properties was anything to the 0 power always equals 1. So no matter what your base is here, if you ever see a big number 1 right here, the answer is always going to end up being 0. Because the only way you can get a 1 is with a 0 exponent. Number 17 and 18. Log base 2 of 64. And once again, I'm going to write it as equals x. That means 2 to the x power equals 64. So you got to count basically how many times you have to multiply 2 times itself before you get to 64. And you would end up getting a 6. Number 18. Log base 3 of 243 equals x. Once again, just through rewriting it, I would say 3 to what exponent equals 243? What you can just do is start off with 243 and divide by 3 once. You'll get a smaller number. You'll get like 100 and something, I don't know. And then you do it again. You get something a little smaller. You do it again. You do it again. And finally you'll get down to where it can't get any smaller. And it would have done that 5 times. You would have divided by 3 5 times. So that's another way you can get these answers if you're not really good with your times tables. But like I mentioned in the last video, you got the time, learn your times tables, at least the ones you're not that strong at. All right, everyone knows like the 5s and stuff. 19 and 20. Log base 9 of the fraction 1 over 81 equals x. Automatically, the minute I see a fraction, I know I'm going to have a negative answer. So I can just throw a negative sign right here. And I know to go from a 9 to an 81, 9 times 9, or 9 squared is 81. So that's where the 2 comes from. And you're done. Now let's go ahead and work in reverse. I have log base 64 equals 4. Oh, excuse me. Log base 64 of 4 equals x. That means 64 to some x power will equal a smaller number. The only way you can make big numbers get to smaller numbers is with fractions. So I can go ahead and just throw, since I'm going from big to small, I can throw a 1 over. And then I can go ahead and start dividing 64 by 4. 64 divided by 4 gives you, I think, 16. And then you divide by 4 again, and you're left with 4. So you would have divided by 4 3 times. That's how you get the 1/3. Or you can just keep playing with different numbers until you get what you want. It's up to you. And finally, our last example of some actual work. the changing of base formula. Now this one, of course, I'm going to be very lenient on. If you even get in the neighborhood of the answers, you're getting full credit for it. And I'll talk more about grading after I finish this last example. So change of base formula. It says some logarithms are not as easy to evaluate as the ones above. Because these ones all had nice whole number, relatively whole number answers, or a whole number was involved in the denominator. And they will require what's called a change of base. So in this case, if you have the logarithm of some base b of a, you can rewrite it another way. You can say it's the same thing as log of a, log base 10 of a, really, over log base 10 of b. You're giving it the same base. There's really an invisible 10 here, like we learned in the rule above. So what you're doing is rewriting it so they have the same exact base. And this is something your calculator is going to do. Now, I know many of us do not have our calculators because obviously they're at school. And there were issues, not your fault, for downloading the Inspire software. But I did mention using Desmos. So what I'm going to do is I'm going to show you how to use Desmos to get your answers here. And I'll do it with these last examples. So first on the side it says choose base 10 because there is a calculator button for it. Yes, and it's actually a function that says log on the calculator, and I'll show you how to get that. So let's go ahead and first rewrite it. They give us log of base 16 of 64, and I guess really what I should say is like equals what? So what is that number going to equal? Log of base 16 equals 64. Our rule above, right here, says when you have something in this situation, in this case 16 is our base and 64 is our a, it says you write it as log a, so log 64, because that's our a, over log of whatever our base is, 16. Log 64 divided by log 16. So now is where you're going to go to your graphing calculator. We're going to go ahead and go to Google, and you're going to go to Desmos. And I'm going to go ahead and just select, you can pick graphing, but you really don't need to graph anything. So I'm thinking scientific should work. This is actually my first time using it as well, but I believe we're going to find what we need. So what I need to do is basically solve this equation. The equation of log 64 divided by log 16. And it should be 1.5. Let me show you how to get that answer. So you're going to go over here to function. And I believe the word here it is, log. Now you go back to, I'm guessing main for your numbers. There you go. Log 64 divided by, go back to function, log, and it's going to be of 16. So go back to main, 16, and it gives us the answer already. So you don't even press enter with this apparently. It just gives you the answer automatically. So 1.5. So that's what you would type into your Google form. I would actually prefer 1.50, but I think I could be flexible enough to take 1.5. Now, and that's what our answer is shown right here, 1.5. Let's practice this again. Log base 8 of 32 equals some mystery number that I guess that we're looking for here. So we're going to rewrite it. I'm going to say the log of 32, log base 10 really of 32, over log base 10 of 8. So log 32 divided by log of 8. You go back to your graphing calculator or Desmos. I guess to clear this out, I'm not sure how we do it. Oh, there we go, clear all. All right, so it was log of 32. A little annoying that we kind of have to keep going back and forth between menus, but there's only a few of these problems, so I suppose we will survive. Over log of base 8. And then 1.66, I see it repeats. So the way I'd want you to respond in your Google form, so that's one with a repeating 6, I want 2 decimal places. Go ahead and give me 1.66 for an answer that has a repeating decimal like that. Let's practice the next one. 23. Next, I'll just show you the last 4. Those of you who might kind of already have the grasp of it, want to go ahead and you can check your answers. Log base 2 of 54. That means we're going to have the common log of 54 over the common log of 2. Because remember, common means we have little invisible 10s there. And if you put in the calculator, you should get this answer. When you put into the Google form, just give me the first 2 decimals, or the first 2 numbers after the decimal. I'm not even going to bother with rounding. We do the same thing for number 24. You would truncate it or cut it off right there. And please just go ahead and give me 2.46. I know you should round it to 7, but I'm going to just ask you to cut it to the last 2 to spare you guys even that extra thought of possibly having to round incorrectly. Number 25, when you do the work, you should cut it off right here. You get 3.54 in the Google form. And then for number 26, you're going to get, now this is interesting. I like this. Log base 6 of 1 over 36. So it's still going to be log of 136. Now let's see how to do that with decimals, because we haven't practiced trying to put in a fraction into the function. So log of 136 over log 6. Let's see how easy that is to do, if it is at all. So I know where to find the log button. That's easy. And then I'll go back to main. And I'm wondering, here we go. This looks like a fraction button right here. There we go. So you press that A over B. 1, I'm guessing if I just go down here and click on it, 36. And then I'll go ahead and just close this out right there. Parentheses. There we go. Divided by log of 6. So even doing that kind of thing with the fractions is not difficult with decimals, and it's pretty easy. And here we get -2, which does represent our answer that we got on our answer sheet here. All right. So do your best on this. I'm giving you passing credit for giving me your best shot. If your answers are totally way off in the ballpark, I might ask you to screenshot your work and show it to me so I can see where you went wrong. Otherwise, I will just accept generally what you turn into the Google form. Get it in by Friday morning, 8:30. I'll be online Tuesday and Thursday of this week, officially from 9:30 to 11:30, which basically means I'll be literally at my computer doing work for other classes, or for myself, whatever I got to do. But of course, you know, if you message me at a reasonable hour during the day, in between then, I can pretty much help you with any question you might have. Make sure your questions are specific. You know, things like I don't get it are really hard to understand and answer, especially from a distance. You know what I mean? So best of luck. And I hope these notes were effective. And I look forward to seeing your answers. And if you have any questions, I'll hear from you guys this week. All right? Have a great day.